Big thanks to the BayREN team and Rachel for having us. So I'm Katie Van Dyke. I'm the Climate Action Program Manager for the City of Berkeley in our Office of Energy and Sustainable Development. And I, along with my colleague Marna Schwartz, are project managing the Berkeley Energy Assurance Transformation, or BEAT project, as we like to call it. And so today what I'm going to do is give a little overview of why Berkeley is really interested in microgrids, and as well as an overview of the project. And I'll focus a little bit on how we selected our team, as well as some of the lessons learned that we've had so far. And so this project really stemmed from our resilience work. So in 2016, we released the city's first resilience strategy, which was part of our work with the Rockefeller Foundation's 100 Resilient Cities initiative. And this strategy really highlighted the city's most pressing challenges and also identified solutions that would bring resilience to our community. And we know that our challenges are interconnected, like climate change and disaster recovery and equity. And so therefore our solutions have to really be integrated as well. And so the way that we view resilience is really as an approach to how we as practitioners in the city do our work. And it's really asking ourselves a question of, when we design our policies or projects or programs, how can we address as many challenges as once, bring as many benefits to the project at once, and bring as many people to the table as possible. And so Anthony talked a lot about, why people are interested in microgrids, and resilience really is the main focus for us, for a lot of the same reasons that he had mentioned, looking at other disasters and how other communities really struggle to recover after those disasters just because they lost power for such a long period of time. And so we think microgrids are a really excellent example of what resilience looks like, because as an alternative to diesel generators, it just brings so many more benefits to the community. And I'll also talk about microgrids as well as kind of the alternative approach, which is solar plus storage, a little bit today, which is just not actually connecting facilities together in a microgrid, but just having standalone solar plus storage. So as Anthony mentioned, microgrids have a lot of benefits. I won't go through all of these, but it just shows what a better solution it is than a traditional diesel generator. So traditional microgrids, what we see a lot of that are built now, tend to be campus level. So one owner on one piece of land, like universities, hospitals, military bases. We also see a lot of microgrids that are being led and designed and financed by utilities. Those are some of the larger microgrids that we're seeing now. And they also tend to be built within new development. And so our project was really focused on kind of the community scale. How can we as cities provide resilience and services to our community in the event of disasters? But we're focusing it a little differently. So what we're trying to do is connect multiple community facilities. So for now, city-owned, and I'll mention a few others later. But these buildings, some of them would have access to solar and batteries, and they would be connected across multiple blocks, which I'll get into why that's tricky. And then we were hoping to aggregate those loads across the buildings, both during normal operations as well as in an outage situation. We wanted our systems to be scalable and replicable, so that we can maybe start off with a simple microgrid but build it up. And in an dense urban area like Berkeley, we're talking about old buildings that often have shading issues. A lot of the buildings we're talking about already have things on the roof, equipment. So a lot of these buildings are not good candidates for Z&E. And what we're hoping is that by putting some of these buildings together and aggregating them, we can get closer to a Z&E community, which is really what we're seeing the future grid look like. Yeah. And so next I wanted to talk a little bit about our project and team. The funding for our project was about $1.5 million as well from the CEC, which we're really grateful for the partnership and opportunity to be able to explore how you can build a dense urban microgrid. And as you can see, we have a wide range of folks on our team. We have some of our team members here today, which is really exciting. We have the BayREN and ABAG team, Jenny and Arietta and Chris have all really helped out a lot on this project, as well as PG&E has been a great partner through this process. They've really helped us try and understand what's possible. And the scope of our project is really to kind of, as Daniel mentioned, this is really a design phase. So we first conducted simultaneous regulatory, technical, and financial analyses on evaluating the possibility for dense urban microgrids. And then we took this information and tried to extract how other communities could learn from us. And we're putting this into a case study that we'll be releasing soon. And then we took all those analyses and also put together what we are calling a shovel-ready design for actually building a microgrid in downtown Berkeley. And I just wanted to note that we will be releasing our case study soon, and it's intended to really just share all the painful lessons learned that we've come across so far so that others can learn from us. So once that comes out, we'll be sure to share that across BayREN and on our website as well. So please be on the lookout for that. And our funding will go through June. So we're also working on our final report, which we're really excited about. And so within our team, we broke out our team into several other subgroups. We knew that this is a complex topic. I myself am not an expert in any of this, and so I knew I needed a lot of smart people to help me figure out what to do. We had a regulatory team, and they were really focused on trying to evaluate what are the state, local, and federal barriers to building microgrids right now, and what are the things that need to change in order for them to be easier to implement in the future. Our technical team, which also included LB&L, was really focused on how can you actually build and design a microgrid, what does that look like with the existing infrastructure that PG&E has, and how do we optimize that microgrid, how big should the batteries be, things like that. Our financial team was focused on how do you pay for this. As everyone mentioned, they are expensive. So how can we pay for the upfront costs of a microgrid, operating and maintaining it, and how can we create some business models that others can follow that could be creative in funding these in the future. And finally, we have our knowledge transfer team, which is largely led by ABAG and BayREN. And the point of that is to really just share all of this information out to others so that we can help others advance this technology with us. And another thing I'll mention in terms of selecting our group was we noticed that there were several funding opportunities that were coming out for microgrids and similar technologies. But as everyone knows, they come really quick. So when they get released, you have 4 to 6 weeks to respond. We're a city and we're a big bureaucracy with tricky procurement policies. So we would not have time to select a team, go through a procurement process, and respond to a proposal in the same 4 to 6 weeks that a private company might be able to be more nimble to do. So what we decided to do was to do an RFQ before we knew that some funding opportunities would be coming. So we did a competitive process beforehand to select our team. And so for any other jurisdictions, that was really helpful because we knew who our team was. So then when the funding from CEC was released, we were able to just jump on it and respond more quickly. So that is a lesson learned that we thought was really helpful. So now I'll talk a little bit about the actual design of our microgrid. It is focused and kind of anchored around an existing city project. And this is the rebuilding of our Center Street garage. So anyone who's been in downtown Berkeley has probably seen it. But we think this is great for many reasons. One is that we're leveraging an existing city project. This project was already going to be rebuilt, but we were able to work with our public works team and the community to make sure that we incorporated as many resilience benefits as we could. So we're actually making it microgrid ready. This is going to be the main generator for the microgrid with solar rooftop on the top. It'll have EVs, and as you can see, there's lots of other interesting fun benefits to the garage, like a stormwater retention system, art display, and we're going to have a bike valet, which is pretty cool. So we like to call it a very Berkeley garage. Like, it's just, we can't just do a simple garage. And I'll be opening sometime this year, which is exciting. And in terms of the buildings that we're talking about connecting, so I said we're talking about community buildings. So we have 2 prototypes that we've designed. One is kind of an initial build out. So a single owner, just the city, 4 city community buildings. And this includes our public safety building, which has our 911 call center, our emergency operations center. It's really important to have have backup power to that building in a disaster. There is existing diesel, but the microgrid would reduce that amount of diesel by about 30%. The prototype 2 would really just be an expansion of prototype 1 to include buildings that are owned by another entity that also serve a critical function. So we're talking about Berkeley High School, which is just across the street. They have a large solar array, and they are our largest and nicest critical care facility in the event of a disaster. We're also talking about the YMCA. They have solar potential, could be a critical care shelter, and then the teen center, they already have a small solar array as well. Our design requires new distribution lines to be installed to connect these buildings because our understanding and conversations with PG&E is that we cannot use the existing lines there. Unfortunately, this is a very expensive solution. This is the most expensive part of building the microgrid, actually. And then another complexity that we've learned along the way is that even though these buildings are really close together, as you can see, because we're crossing the public right-of-way, there's a state rule that says that you have to be a utility to own and operate those new lines if you want to pass power every day. So that's another kind of issue that we came across. So the current concept, and we're talking about owner-operator models, is that we would build and pay for those distribution lines and then deed them over to PG&E, and then PG&E would be the owner-operator of those lines if they agreed to it. And so that's the concept, but there are still some, very, very important financial implications that go along with that, such as what types of tariffs and rates do you use in that type of agreement, and how could you potentially integrate other customers. So these are all things that we need to be figured out in order to actually build this. And so as an alternative, because of all these complexities, we are looking at solar plus storage too, and I'll talk about that a little bit more. But I did want to chat about some of the lessons learned that we've had quickly. One is that they are possible. It's technically possible to build a community microgrid, but that being said, they come at a cost, which is true of most technologies, new emerging technologies, but it's more complicated because the tariffs that exist weren't really developed with microgrids and resilience in mind, so you're kind of working in a different framework. And as mentioned before, they do require utility participation, or they could be municipally owned, but you do need a utility involved if you're crossing the public right-of-way. And so through our project, I think what we've learned a lot about is kind of, in order to build a microgrid like this now, there's a certain set of criteria that makes it a lot easier. Daniel talks about, they wanted to pick a really hard nut to crack, and we kind of did that. We didn't really know how hard it was going to be at the time, but we found along the way that there are certain criteria that will help a community build something right now. One is just infrastructure feasibility, and what I mean here is looking at the existing infrastructure of the buildings you're talking about connecting and seeing if there are opportunities that can make it more optimal for a microgrid. For example, from our understanding and conversations with others, if you're at the end of a distribution line or in a rural area, not in a dense area with tons of customers like we are, that makes it a lot easier. Also, if there's an area where there's deferred maintenance potentially, that also makes it easier. And ideally, it would be great if you could use existing distribution lines. Another criteria is, it's really beneficial if you can have a large amount of solar and storage. This can help not only the buildings themselves, but it's also an incentive for the utilities or the CCAs, whoever you're working with, to get involved because it helps them meet their RPS and storage requirements from the state. So that's another benefit. Thirdly, if your microgrid can aggregate power without having to cross the public right-of-way or get a utility involved, that's really beneficial. And the ways that you can do that are, one, if it's a campus style, which you knew. Two is if they're directly next to each other or contiguous. And then three is if you have a municipal utility. So those are ways that you can kind of aggregate your power on a daily basis. Fourth is, as we said, you need a partnership with the utility and technical experts. For example, we're seeing, as I mentioned, in Maryland, they're doing some microgrids that are actually being led by utilities. That's really exciting. And finally, these projects are very expensive, so they do require both seed funding and match funding, because many of the seed funding opportunities, you need to bring to the table at least 20% match. So for cities, and some entities that's difficult to come across. So these are all just kind of some things that we've learned about. And as I mentioned, our project doesn't meet all of those criteria. So we realized that we do have some challenges in order to build right now under current conditions. For example, we're pretty small on the solar side. As I said, we're dense. We have old municipal buildings that are not all great candidates for solar. So we're about less than 500 kW. We can't use the existing distribution lines. And we can't share the power between the building and blue sky operations is what we've been told so far. And it's very expensive, as I said, to install new distribution lines. And that's not just the upfront cost, but there's also a one-time tax and some operation and maintenance fees that are pretty high as well. And then again, needing to, we have to work with the utility to own and operate the distribution lines. We're not a municipal utility. And then finally, there's really no rate structures or tariffs that are developed already to help benefit both the microgrid customers as well as the utility. So that's something that really kind of needs to be developed in order to move these forward. So all that being said, due to some of these barriers, we are considering solar plus storage as an option. This still provides a lot of resilience benefits to our community. We can still provide clean backup power to several of our critical facilities and reduce costs. And this is a very proven technology that we know works, and it actually has a positive return on investment. This is the only scenario that we model that actually has a positive return on investment because we don't need the new distribution lines, and there are no barriers. So this is also a great option for other communities to look at too if some of those barriers are too tall to build a microgrid right now. And it could also always be expanded into a microgrid once some of those challenges have been resolved. But a couple of the drawbacks of this is that they are not connected. So in an outage, you can't share the power. And on an everyday basis, you can't share the power. And for us, this means that one and maybe two of our buildings wouldn't be able to do solar plus storage just because there's no rooftop availability there. So it kind of limits, it's limited to your building stock that you're looking at. But all that being said, we've learned a lot in our project, and they are possible to build, but again, there are some challenges that exist. So I think, really depends on what jurisdiction you're looking at and what areas and what buildings, but there are some great options to provide resilience. So that's all I had for now, and I look forward to questions if there's time. Yeah. Okay.
Mark Monterino at Arup again. When you were looking at new distribution lines, I assume that PG&E wouldn't let you use their existing lines, probably because they were worried about capacity. Did you engage PG&E about using maybe spare conduits that they had in their right-of-ways, or were you thinking about, I guess, tunneling for new lines entirely?
So the reason why we can't use the existing distribution lines, and David's in the back, so please correct me if I'm wrong, is because we're in this really dense urban neighborhood, and there are apparently hundreds of customers between the buildings that we're talking about. So in the event of a disaster or a major grid outage, we were told that each customer would have to be manually shut off. And we would need a contract with each of those customers to say, hey, in the event of an outage, other people are going to get turned on, but you're going to stay off. And so that in itself was too complex to take on for the scale of the project that we're talking about. So yeah, what we were talking about is entirely new lines, trenching and digging new lines. I don't know if we talked about that specifically, but I know that we looked at all the existing infrastructure that's in there, and one of the challenges of trying to do this in a really built out environment is there's so much happening in there already that it was deemed to be the most kind of the safest, most efficient way to run the system is by doing new lines. But I've been told that there is potentially the technology to automatically switch off customers, but that would again have to be widely adopted by the utilities, and then there would still be the issue of having a contract with the customers.
Just to build off that, the distribution lines, how much is it in detailed in the report that's going to be held as far as the O&M and then the tariff and tax?
It will be, yeah, so we have all that information. I think it'll be more summarized in the final report, but if anyone wants any of the really detailed nitty-gritty, we'd be happy to share it with you.